we're going to identify functions, and functions are simply dealing with the x value. So we're looking at the x value and how it relates. So two ways of doing this is looking at the x value as long as they don't repeat. So the x value does not repeat, you have a function. So we look over here, and on the domain is the x value, and you have a -2, 0, 3, and 4. They're all different numbers, so this is a function. Same thing here, we have 1, 3, 5, 1. They repeat. Ones repeat, so this is not a function. If we look at the x values, we have a 2, 3, 3, 2. The 3's repeat, and the 2's repeat. It doesn't take 2 to repeat. It only takes 1, and so this is not a function. The second way, this is the first, the second way of telling a function is doing what's called a straight line test. That means if you have a graph and I have a straight line and I run it across this graph, a straight line, and it never touches the graph twice, it's a function. So this is a function. The next one is not, because it touches right here. It touches that straight line in 2 spots right there. So this is not a function. And if you look at this one, if I run a straight line, even though it looks like it touches right there, if you look at that problem, let me do this real quick, erase that. Right there, that's not part of the graph, so it never crosses twice, so this is a function. Okay, now we're going to take some data given in a word problem, and we're going to organize it in a table first. So I'm going to get my table, and we have teams, and we have feet. So my first, team 1 has 4 feet. Team 2 has 4.5 feet. Team 3 has 3.2 feet. Team 4, 5.1 feet. And Team 5 has 4.8 feet. So there's our table. Now we're going to do the domain and range. And the domain is all the x values. So we have 1, 2, 3, 4, and 5. The range is just their feet. So we have 4, 4.5, 3.2, 5.1, and 4.8. The next thing is ordered pairs. So ordered pairs is putting our x value with our y value. So we have these as our ordered pair. And now the next thing is we're going to see if it's discrete or continuous. To do that, we need to graph it. So I'm going to graph this. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 1, 4, dot right here. 2, 4.5 up here. 3 and 3.2 down in here. 4 and 5.1 is up here. And 5 and 4.8 is just below it. So we have our dots. If the dots don't line up in a straight line, they are discrete. So the answer to this is discrete. If they are in a straight line, and if I'll just put some red dots as an example, then, or they lined up where they went right in order, we'd have, this is called continuous. But that's not the case for this example. This one's discrete because the lines, or the dots, are all over the place. So once again, we want to take our information and we want to go through. So A is we want to make a table. So we'll make our table. So we have our quarts and the weight. So 0, 2.3, 1, 6, 2 is 9.7, and 3 quarts weighs 13.4 pounds. So there's our table. Our domain and range, the domain is the x values, so these are the x values. So the domain is 0, 1, 2, 3. Our range are the y values, 2.3, 6, 9.7, and 13.4. Our ordered pairs is 0 is with the 2.3. Our 1 is with the 6. Our 2 quarts is with the 9.7. And our 3 quarts is with 13.4. And now to find out if it's discrete or continuous, we need to draw a graph. So I'm going to draw a graph. So we have 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So 0, 2.3 is somewhere right in here. 1 and 6, 2, 3, 4, is up here. 2 and 9.7 is up in here. And 3 and 13.4 is up here. Notice that they kind of line up and they kind of form a line. So this is continuous. So to determine whether an equation is a function, we're going to create a table of values. That means we're going to create what x is. And in this case, we can use any number we want. So I'm going to use easy numbers like 0, 1, and I'm going to use a -1. And so if I put 0 in for x, and I want to know what y equals, in this case, the y value would be 8. If I put 1 in for x, I have a -4. What would I have to add to y to give us 8? If I take the -4 and move 3 and move it over, I would get the y value of 11. And if I put a -1 in, I get a +3, and I get answer 5. So once you have 3 values, we can then go over and graph those values. So 0 and 8, 3, 4, 5, 6, 7, 8 is up here. 1 and 11 is up here. And -1 and 5, 1, 2, 3, 4, 5 is right here. And if we connect those 3 dots, we get a line. All lines are functions except a vertical line. And a vertical line is one that goes straight up and down. So this is a line, so this is a function. So the answer is function. Now sometimes they give you what's called a function, and we want to find the value that's given to us. This is what's called function notation. It's the same thing as y equals a -4x plus 7. And if we look at it this way, we can make a table, and we can put x, and we can put our function, and our x is what's inside the parentheses, so that's 2. So we're going to use 2 to substitute, and that gives us the y. So -4 times 2 is -8 plus 7 is a -1. So our answer is a -1. So there's our x and our y, and oftentimes it's put in ordered pair form. So this answer actually equals a -1. So doing functions is simply taking within the parentheses and substituting it for x, getting an answer, and that's what the f of x equals. So this would be our function answer. So let's look at this problem over here. I want to substitute this -3 for the function. So I'm going to write a -3, and I'm substituting it into the function. and get the answer. That's a negative 12 plus 7 equals 5. Now, this part equals 5, but we have a plus 1. So the whole answer then is 6. So this notation simply means to substitute for x into the function or equation that's given to us.